Assuming we make the empirical assumption that the mean and volatility of annualized returns are 0.24 and 0.67. Further, assuming there are 250 trading days in the years, calculate the normal 95% VaR and log normal 95% VaR at 1 day holding period for a portfolio worth $1. So based on the annualized return and volatility, let's calculate 1 day return and 1 day volatility first. So 1 day return becomes 0.24 divided by 250 equals 0.00096, and 1 day volatility becomes 0.67 divided by square root of 250 equals 0.0424. So now we know 1 day return and 1 day volatility. So let's carry on to calculate normal 95% VaR. VaR at 95% confidence becomes minus mu plus sigma z, so minus 0.00096 plus 1.645 multiplied by 0.0424 equals 0.0689, so 6.89%. And log normal VaR at 95% equals 1 minus e powered by mu minus sigma z equals 1 minus e powered by 0.00096 minus 1.645 multiplied by 0.0424 becomes 0.0665, 6.65%. So answer is B. Next question. Assume the profit loss distribution for XYZ is normally distributed with the annual mean of $20 million and standard deviation of $10 million. 5% VaR is calculated and interpreted as which of the following statement? 95% VaR is minus mu plus sigma z, so minus mu 20 million plus 1.645 multiplied by standard deviation 10 equals minus $3.5 million. VaR represents loss, and negative VaR implies that it has a high probability of making profit. So the interpretation of this question becomes that company XYZ will earn less than 3.5 million with a 5% probability, which is equivalent to that the company will earn at least 3.5 million with 95% probability.